Good afternoon, everyone. I am Camilla Roversi Monaco, a paper conservator and professor at the Academy of Fine Arts in Bologna. The work we are presenting today addresses a very specific theme that is part of a broader project. My task is to briefly contextualize the conservation work conducted by Francesca Incoronato for her thesis within the framework of conservation and preservation activities that we have been carrying out for approximately 20 years on the Antonio Basoli collection. Basoli was a celebrated set designer and a decorator who was active at the Academy of Fine Arts of Bologna, first as a student and from 1803 as a professor. The drawings and prints cabinet of the Academy houses the most complete graphic collection of this artist, who was a central figure in Bologna's 19th century artistic scene. The collection was created after his death in 1857, with the intention of offering students an iconographic reference point. It consists of 28 manuscript volumes and over 10,000 drawings and engravings, mostly mounted in albums, through which it has been possible to trace the stylistic and technical evolution of this prolific and versatile artist. Between 2002 and 2004, 25 years ago, I was commissioned by Bologna Cultural Heritage Authority to treat two albums. Album 102, which contains Basoli's early work, as well as numerous work by other artists who inspired him, and album 105, perhaps the most famous album, which contains the most important architectural projects, both executed and unexecuted, for decorating the houses of noble family of the city. A second substantial phase of the conservation treatment was implemented between 2007 and 2008. Many drawings were removed from the albums to allow for their display during the most important exhibition dedicated to the artist. However, all these commissions did not include the reassembling of the volumes. When I became an internal professor at the Academy of Fine Art in Bologna, I began with my colleagues to systematically plan their recovery. Thanks to teaching activities, the following work has been carried out, all of which has also been a research opportunity. Between 2017 and 2018, album 105 was reassembled and album 43 was treated thanks to Giada Scarabelli's thesis work. Between 23 and 24, a general reorganization of the entire collection was carried out, and 2 more volumes were restored, thanks to Francesca's thesis work. Currently, we are carrying out a reassembly of album 102, which will be the subject of Anna Giorgia Giambelli's thesis. Finally, several exhibitions have been organized by my colleague Professor Eleonora Frattarolo to promote and make known this important collection, with substantial contributions from students during the installation phases. This intervention have allowed us to evaluate the effectiveness of previous work and to make necessary modifications where needed. The most significant example is the removal of the 960 small hinges, not so funny, that I applied to the 240 artworks in album 105. Since the water-based adhesive chosen was not sufficiently strong to guarantee a secure mounting to the album pages. These hinges have been replaced with others made with Preglude Bondina, a solution that was unknown 20 years ago, and which has also been adapted for the conservation treatment we will present today, both to ensure the uniformity of intervention within the collection and because it is considered the most effective.
Good morning, everyone. I'm Francesca Incoronato, and as Professor Camilla Roversi Monaco just said, I'm going to talk about part of my thesis project, focusing the attention on the technical process related to Basoli engraving workshop and how the conservation treatment on its work has been managed. From 1810 to 1839, Antonio Basoli led a series of successful printing projects carried out on his engraving workshop with his brothers and his students' collaboration. And among these, there are the Vedute Pittoresche della città di Bologna, published the incomplete version for the first time in 1836 and object of the present study. The 100 views consists of a collection of prints engraved using the etching and aquatint technique depicting 19th century Bologna in all its artistic beauty, but also in the everyday life details. Stored in the cabinet of drawings and printings of the Bologna Academy of Fine Arts, there are two albums entirely dedicated to the views. The first one is the album 98, bearing the preparatory drawings, while the second one shows the complete printed edition. Both albums have an index in which Basoli dated each view based on the execution of the corresponding oil paintings. Thanks to these valuable information, a wide research was carried out within the collection, and many iconographic references have been found in other sketches books and albums in the collection, outlining all the stages of each subject before being printed. The key to understanding the technical processes used in Antonio Basoli engraving workshop lies in the preparatory drawings contained in album 98. This is a material complex object, and through scientific investigation and archival research, it has been hypothesized that the preparatory drawings were transferred by direct contact onto the copper plate, thanks to the use of a handmade copy ink and impregnated papers. The album 98 is made of backing pages where the preparatory drawings of the view are mounted. Each page derived from other drawings executed with different techniques such as pencil, iron gall ink, and watercolor. The 95 preparatory drawings of the 100 views seems to share the same ink made of red chalk, but 16 of them are characterized by a very thin impregnated paper. To determine the technique, different elements suggested how those drawings weren't simply executed as a reference for the engraving process, but were used as a matrix to transfer directly on the copper plate. The first evidence was found in the plate mark sign present on many of the drawing surface, bearing the same dimension of the one found on the final prints. And numerous drawings also have black signs, in particular on the edges, with a regular shape that could be related to clamps used to bring into register the copper plate during the printing process. Thanks to the drawing comparison with other tracing papers stored in Basoli collection, interesting similarities were found. After the temporary dismounting of the preparatory drawings from the album pages, there were noticed the same alteration features of the copy ink used for tracing papers, suggesting the same material for the preparatory drawings of the views. Furthermore, UV light and higher radiation response between the preparatory drawings and other works stored in the collection gave more information that confirmed the hypothesis. Observing the album 98 backing pages, it was noticed that the one that presents the so-called by the author clumsy tracing papers give the same fluorescence observed on the preparatory drawings made of the thick paper. Regarding the preparatory drawings made on thinner supports, it was noticed that they show the same yellow fluorescence, so on the backside of each table of the printing album, characterized by the migration of the entire ink binder. Those results were crucial to conclude that every preparatory drawings were treated with an impregnated substance, changing the approach to their conservation treatment. During the preliminary investigation, another comparison was performed through IR photography, and the results showed the transparency of the preparatory drawings ink and the clumsy tracing paper as well, suggesting a similar composition and consequently the same execution technique. Another evidence that demonstrates Basoli knowledge in copying processes was found in 12 of the thin impregnated papers. Their analysis in transmitted light show the marks James Watt & Co. patent copying. This type of paper was sold with the copying machine invented by James Watt to gain multiple copies from a single document. It is therefore possible to assume that Basoli learned the technique inspired by this machine, using a similar material available in his engraving workshop. All those elements point out the pattern to follow to determine the material used for the preparatory drawing and to confirm the hypothesis of the direct transfer process onto the copper plate. The execution technique was studied deeper through historical research and comparison on copying ink applied to documents. In his autobiography called Vita Artistica, Basoli mentioned a specific technique he used to get multiple from a single drawing. The material consisted in handmade ink made of sugar, the employment of an impregnated support, and the application of high pressure through a printing press. This process is very similar to the one explained in the instruction manual of the copying machine by James Watt. In order to make a copy, it was necessary to prepare the paper sheets by leaving them inside a dumping box with a precise amount of water. To make a copy of the document, James Watt recommends letting the copy ink to dry and then simply spread a sheet of damped copy paper over the surface of the text, place everything between boards, and proceed with a double press between the rollers. The copy ink used was iron gall-based, with sugar or gum arabic as an additive to inhibit the oxidation of the ion salts and to gain 24 hours to make a copy. From one register where Basoli wrote the list of pigments and binders he usually wrote, he noted gum arabic and sugar as well, suggesting its possible use for the handmade copy ink preparation. This hypothesis seems to be plausible, but further studies need to be conducted by specific investigation of the binder ink nature used for the preparatory drawings. In order to try to confirm the process technique to characterize materials and subsequently design the best conservation practice to apply, a wide-range diagnostic campaign was conducted on 5 preparatory drawings of the views made on the thin impregnated papers. The multi-technique analytical protocol applied involved the use of non-invasive and micro-invasive analysis, ion beam analysis, hyperspectral imaging, and force analysis provide detailed composition maps of pigments and supports, and at the same time, analysis through SEM-EDS and FTIR-ATR allowed molecular characterization of non-replaceable microsamples, completing the cognitive framework with information on the chemical composition and structure of materials. The 5 impregnated drawings were subjected at first to multiband imaging analysis to highlight the characteristics of the material used, and in particular those relating to the substance employed for the support's impregnation and those relating to the ink composition. IR radiation confirmed the transparency previously noticed related to iron presence of sanguine ink, while the black stains, presumed as Judean bitumen or Entaio ink residues, were found to be completely opaque. The presence of bitumen or Entaio ink, composed both of carbon, would explain the results, confirming the initial hypothesis. UV luminescence on the 5 drawings showed an intense yellow fluorescence, and the response is characteristic of oil-based film coating, traditionally used to produce impregnated papers. UV radiation also allowed to make some consideration about how each paper reacted to the impregnation process due to their morphological characteristics and their manufacture. Ion beam analysis technique allowed to get information on the composition of a sample by observing the products of interaction between it and a beam of accelerated particles with an energy in the MeV range. The instrumentation used to carry out the analysis consists of a Tandetron 3 MeV particle accelerator using the total IBA analytical system that include PIXE, PG, and RBS analysis performed at the same time. The various measurements taken on the red inks highlighted the same element, in particular iron, but in different concentration, confirming the composition made of sanguine. IBA also gave other information about the black stains. Measurements revealed a relevant concentration of lead and copper attributable to residues belonging to the copper plates, confirming the direct contact with the drawing. Paper characteristics were outlined thanks to SEM application on microsamples, and the images obtained shows clearly cotton fibers. Furthermore, it is possible to notice how all the fiber samples are surrounded by the oil substance used for the impregnation. Quantitative analysis was ensured by the synergic use of the IDX microprobe to obtain semi-quantitative information about the paper composition. Despite the analyzed paper have different origins, the presence of the same elements associated with the fillers involved in the paper manufacture process were detected. FTIR-ATR allowed the molecular characterization of the impregnated substance, and the spectra detected the presence of a broad band compatible with the products of oil degradation. Based on the evidence found following the analysis, the impregnated substance was finally defined as linseed oil. The analysis performed to the 5 drawings led to concrete results, confirming the impregnation substance as linseed oil, the copy ink made of sanguine, and giving information regarding the different paper supports. Thanks to the results, it was possible to design and perform a more aware and respectful conservation treatment now described. The 16 thin impregnated papers required a specific treatment. Following careful assessment, it was recognized that the combination of mechanical and chemical damages had made the paper supports extremely fragile. For these reasons, lining treatment have been chosen to provide the right support and stabilize the drawings. The first operation consisted in humidification treatment performed through a sandwich structure made of wet blotters and sympathex. For lining treatment, it was chosen a 6-gram Japanese tissue selected because its homogeneous surface compared to other tissues, which, despite having a lower weight, have areas of great density that could have been visible, affecting the drawing appearance. The water-based adhesive selected was Stylose MH300P at 3%, and the most beneficial effect of its use is related to the increase of pH noticed after the treatment and the general reduction of the yellowing derived from the partial removal of the degradation products of the impregnated substance. The line drawings were left to dry under pressure in a sandwich pack made of remain, dry blotters, and cardboards, and at the end of the treatment, the flatness recovery was noticeable and stable. 2 of the thin impregnated drawings require additional treatment through anhydrous methods. The drawings had 2 joints of thicker paper, bearing part of the drawing lines. To allow the lining operation, it was necessary to detach temporary each element through a dry removal using a stainless steel spatula, and the joints were treated separately with capillary humidification using a sympathex membrane and their flatness recovered between felts under low-pressure press. At the same time, it was possible to line the 2 drawings on thin paper as before described. Once the element had been restored, they were reassembled with Japanese tissue pre-coated with Plexol B500 in water, reactable with butyl acetate solvent. The use of this technique preserved the flatness acquired from lining, taking advantage of the rapid evaporation of the solvent. Furthermore, the adhesive penetrated the Japanese tissue used for lining, enhancing its tenacity and at the same time avoiding direct contact with the impregnated paper. A similar approach was applied for the loss integration, and the same pre-coated Japanese tissue was applied, but before it was properly dyed with acrylic colors, achieving acceptable results in terms of appearance. The lining treatment recovered the lost mechanical strength during the aging process, although the addition of moisture can cause dimension variations and morphological changes. For this reason, it was therefore decided to conduct a brief study of the 16 linseed oil-impregnated paper, monitoring a series of factors before and after the intervention, in particular color variation, transparency, gloss, dimensional stability, and pH. The color variations after the treatment are justified by the partial removal of soluble acidity products thanks to the water-based adhesive involved, without completely extracting the impregnated substance. The comparison carried out to examine the transparency of paper consists of an empirical observation in support through transmitted illumination. Every drawing preserves its semi-transparent characteristics. The gloss variations remain minimal and are closely related to the addition of lining paper, which, although lightweighted, contributes to measurements of the values. The dimensional variations appear to have led to a minimal increase in size, and this phenomenon can be attributed to the humidification and drying process carried out under pressure. While pH measurements confirmed the secondary beneficial effects of the lining treatment, bringing the supports to acceptable valuable in 100% of cases. Once the restoration treatment was complete, the preparatory drawings were placed inside the album using a V-hinge mounting method, and the mounting was performed with pre-coated Bondina and Plexol B500 thickened with 1% of Clusel-G. The mounting operation was performed after monitoring the 2 albums of the Basoli collection, which had undergone previously restoration in 2018, and where the same material and type of mounting have been applied. The previous restored albums showed a stable and resistant mounting, optimal in terms of compatibility with all the supports and graphic mediation, and completely reversible. Finally, the historical, technical, and scientific research carried out during the reconstruction of the 100 Vedute Pittoresche della città di Bologna allowed the process and material characterization used by Antonio Basoli and his craftsmen in his workshop. The synergy between bibliographic information and data obtained confirmed how the multidisciplinary approach to the work of art determines its understanding and recognition, fundamental condition for their proper conservation. Thank you for your attention.